In this video, I would like to look at how we find the area of a rhombus. Let's do a quick sketch. To find the area of a rhombus, we use the formula area is equal to base multiplied by perpendicular height. The base is usually the bottom or the top of the rhombus. In this case, let's say the base is side CD. Let's make it blue. Now let's look at the perpendicular height. The word perpendicular tells us that there is a 90-degree angle between two lines, but a rhombus does not have any interior angles of 90 degrees. So in this case, angle D and angle C are not 90-degree angles, which means that AD and BC are not perpendicular to the base CD, and we cannot use the lengths of either of these sides as the perpendicular height. The perpendicular height is the length of a line running from the base to the top of the rhombus, perpendicular to the base. In most diagrams, you can use the square 90-degree angle over here to determine the line that shows us the perpendicular height. To better explain how we find the area of a rhombus, let's look at an example. In the rhombus VWXY below, ZX is perpendicular to VY, VZ is 8 centimeters, and XY is 13 centimeters. Calculate the area of the rhombus VWXY. To find the area, we're going to use the formula area is equal to base multiplied by perpendicular height. The first thing we need to do is find our 90-degree angle. So let's make it red. This angle lies between VY, one side of the rhombus. This is our base, so let's make it green. The other side is our perpendicular height, so let's make it purple. And now please be very careful here. We can see that VZ is 8 centimeters long, but this is only a section of the base VY. The question tells us that XY is 13 centimeters, and we can see it on the diagram over here as well. This is one side of the rhombus, and we know that all four sides of a rhombus are equal in length. So we know that our base, VY, must also be 13 centimeters long. And as our reason, we say all sides of the rhombus are equal. Now we need the length of the perpendicular height XZ. So let's take the green line out of the diagram. XZ lies in the right angle triangle XYZ. So let's make this triangle purple. We can use Pythagoras' theorem to find the length of XZ. We know that XY is 13 centimeters long, but before we can find XZ, we need to find the length of YZ. We know that VZ, let's make a note over here, is equal to 8 centimeters because this information has been given to us in the question. We also know that VY is 13 centimeters. So to find the section over here, YZ, we can say YZ is equal to the whole length, 13, minus the length of VZ, 8, which gives us a length of 5 centimeters. Now let's put 5 centimeters into our diagram and we can make some space. In triangle XYZ, XY lies directly across from the 90-degree angle. So XY is our hypotenuse. So to find the length of XZ, we can say XZ is equal to the length of the hypotenuse, XY squared, minus the other known side, YZ squared, all under a square root. XY is 13 centimeters, so we say 13 squared, minus the length of YZ, which we know is 5, squared, all under a square root. Now we can take our calculator. We say the square root of 13 squared minus 5 squared gives us 12. This is the length of xz. Now we have a base of 13 centimeters and a perpendicular height that we just found to be 12 centimeters. So now we can find the area of the rhombus. So we can say area is equal to the length of the base, 13, multiplied by the perpendicular height, 12. Now let's take our calculator and we say 13 multiplied by 12 gives us 156. So the area of the rhombus is 156 centimeters squared.